Welcome to How to Think and Talk Math. I'm Mr. D from Mr. D Math. If you haven't met me before, I am a middle school and high school curriculum writer, and this is right where I start with my students who are doing pre-algebra. They start with my courses in pre-algebra. They go all the way through up to pre-calculus, getting them ready for college and college level math. But let's start with how to think and talk math. Here we go. So I'm going to ask you this question. What languages do you speak? So think about that. What languages do you speak? So you might be saying right now, well, I speak English, a little bit of Spanish, maybe some Mandarin Chinese, whatever it is. But did you notice that what you didn't say was that you said math is a language that you speak? Most people think that math is not a language at all, but let's just check it out and see whether or not it is. Let's define math as a language. Is it a language? Well, the definition of language is this: a systematic means of communicating by the use of sounds or conventional symbols. So let's apply math to the definition and see if it works. First of all, is math systematic? That's why it's red and underlined right there on your screen. It is actually. Think about that. Is there a system to math? Sure. There's ways that you do things. You have to have a particular system. Think about when you're working with fractions. Whatever you do to the bottom of a number, you have to do to the top of a number. There's actually a reason for that, but it's part of the system. Can we communicate with math? Well, if I say to you 5 plus 5, the response is 10. You notice that I didn't say, well, I would like you to add 5 and 5, or what happens when you get 5 and 5 and you count 5 things and count 5 more things? All of those things like that. Well, not at all. If I just said 5 plus 5, you automatically say 10. So we're communicating. So we have a system by which we can communicate with, and do we have the use of sounds or conventional symbols? Well, let's check it out. If you were going to read at the bottom of the screen here, and I'm going to put my little pointer right there, and I'm putting around that right there, that thing, and most people see that thing and they go, oh, that's a 3, and then a plus sign, and then a 4, and then a times sign, a 5, equal sign, and then 23. Now, my question is, if I read that from left to right, you'd say 3 plus 4 times 5 equals 23, which it does. However, you might be saying, well, wait a minute, why isn't it 35? How come you didn't do 3 plus 4 times 5? Well, that's part of the system. We'll talk about that in a little while. But just get to the fact that you can read that using conventional symbols and sounds. Notice here that you said this is a 3. Now, that's not actually a 3. You know, it's kind of a curvy thing that curves around, as you can see there. It's not really a 3. It's the symbol that we use to represent a 3. The next little thing, I don't know about you, but it looks like a T to me. Well, maybe not a T, but you're saying, no, that's a plus sign. Really? Okay, fine. Then that's the symbol we use for 4. That's one of the symbols we use for 4. There's another one that we use for 4. But look at this thing right here. It's an X. Now that's the letter X, but you said multiply. 4 times 5. Looking at that X, so it looks like the letter of the alphabet to me. As a matter of fact, when I was making this slide, I actually used the letter X, but you read it as a times sign. Now, do you know what we do to young people? Not only do we tell them when they're in grades 2, 3, 4, the first time they see multiply, they see that X and it means multiply, and then we turn around when they get to pre-algebra and algebra 1 and we say to them, oh, no. It doesn't mean multiply anymore. Now it actually goes back to being the letter X to represent a variable. Not very nice what we do to young people. So what we want to do is work with them on developing math as a language so they know how to speak the language and how to think the language and how to talk the language. All right, well, let's keep going here and see. Now that we've determined that math is a language, I hope you'll agree with me, knowing that the definition of a language, we have a system, we can communicate, and we're using sounds or conventional symbols. So here we go. Let's keep looking at the idea of what I say is the collapsing of the English and math language. So what I mean by that is this, is that because you might be an English-speaking person as your native speaking language, then what we've done is we've taken that English language and stuck it in the math language because your math coursework is actually written using English words. But that doesn't mean it belongs there. We've actually stuck them together. So we're going to uncollapse that. What do I mean by that? Well, think of this. You wouldn't say that the Spanish language belongs in that same circle. You'd put Spanish in its own circle. You're like, yeah, I would. Okay, well, very good. Well, if you would, then why don't we go ahead and separate all three, and let's have math be math, English be English, and Spanish be Spanish. Kind of a cool way to look at that. Math is its own language. Well, what about dog language? Well, I'm going to introduce you to my virtual dog, Skipper. Now, that's Skipper the dog, and I have to tell you why I specifically like Skipper so much is he is a virtual dog, which means that that's all Skipper does. He just sits there and stares at you, and he's cute and exciting, but he doesn't bark. I don't have to take him out to go to the bathroom. I don't have to give him a bath. I don't even feed him. He just does that all the time. I can say, hey, Skipper, what's up? And Skipper says whatever he says, which is sometimes nothing at all. He just looks at me with that funny, cute look on his face. Okay, well, what does that have to do with dog language? Well, check this out. If I'm talking to Skipper, I might say to Skipper something like this. By the way, think about your dog. And if you have a dog or you know someone who has a dog, what words do the dogs you know? Well, usually dogs know words like sit. They know their name. They know something like the word go or eat or treat or roll over, park, all the different kinds of things like that. But what about all the other words? Well, very few words in dog language actually mean anything to a dog. What do I mean by that? Well, it's like this. I say to Skipper, Skipper, today we're going to the park. Are you ready to go? What does Skipper hear? Because he doesn't hear everything. He only hears those words in red. By the way, if you have teenagers, this is sometimes how teenagers listen to you as well. They hear it more like this. They hear their name, and then they hear a bunch of blah, 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 until something important comes along, like park for Skipper, a bunch more blah, 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 and then the word go. So for Skipper, he only hears his name, a bunch of stuff that means nothing to him until he hears a word that does mean something, like park, and then a bunch of stuff that means nothing until he hears the word go. Well, math language is a lot like dog language, because not every word in your spoken language has a meaning to a dog in dog language. The same is true in math. Not every word in the English language actually means something in math. Now you may be thinking, well, that actually makes sense. So our job, my job to work with young people is this. Let's get the words in English that actually mean something in math so that young people know what those words are, and then the rest of it for them can be blah, 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 blah. Okay, well, let's keep rolling. Think about if you're going to read this. If I said, okay, here's a word problem, and you're like already having some opinions about word problems, like saying, oh, I don't like word problems, and oh, I wish you didn't have to do word problems, and notice the opinions you have about them already. If I said to you, what was the first thing you would do? Most people say they would read it. Okay, well, if you were going to read it, where would you start reading? And your answer would be, well, at the beginning, of course, silly. Okay, well, I'm about to say something totally silly. Really bad place to start. And you're like going, what? Why do you say that? Well, check this out. If I read it like this, Mara has a reading project due in 5 days. She needs to read 180 more pages to finish her book, and then she can create her project. If she's already read 100 pages, how many pages will she read altogether? Think of a young person reading that, and by the time they get to the end, they're thinking to themselves, I don't even know what that said. What am I supposed to do with that? What are they asking? Who is Mara? What kind of a name is that? And they start creating opinions about what they read as opposed to actually just getting to work on solving the problem. Sound familiar? Probably does. So let's check this out. What if I started with the question first? What if I started with looking for, where's a question mark? Right there. And this really amazing thing's going to happen. If I back up from the question mark to either the beginning of a sentence or a comma, I'm going to see where the question is. So if I back up and I say, back up to a comma right here, I can see how many pages will she read altogether. Now, if I say that to you without reading anything else, and I just say, how many pages will she read altogether? Your brain automatically starts to try to figure it out. But if I start reading from the beginning, if I start with Mara has a reading project due in 5 days. Oh, I hate reading projects. Oh, I only have 5 days to do it. Oh, she needs to read 180 more pages. Oh my gosh, that's a long book to finish. And then she can create it. And she has to do a project afterwards. And she's already read, oh my gosh, she's got so much more to do. Poor Mara, I feel bad for her. Do you notice all the opinions I start to develop just by reading it from the beginning? But go back to the question. How many pages will she read altogether? What do you mean altogether? How many pages? Well, watch this. Altogether actually tells me, altogether, think about it. What does the word altogether tell you? Well, probably you're probably saying, well, it tells me to add some stuff together. That's what we're going to do. What is she adding together? Well, she's adding pages. So what I'm going to do is I'm going to go back into the problem and look for the word pages and see what we've got. How many pages will she read altogether? What does that mean? Let's look. So do you notice here? She needs to read 180 more pages. Well, 180 more tells me to add on 180 more or 180 plus something. Plus what? Well, she's already read 100 pages. So 180 plus 100 pages would give me my total that we need to see how many pages she's going to read altogether, which would be 280 pages. Here's what I want you to consider. Some of you are saying, well, I always go in and look at all the numbers first. Well, if you look at all the numbers first, if you notice where it says 5 days, which you can see is right here, 5 days has nothing to do with the problem we're being asked or the question we're being asked, which is how many pages will she read altogether? She has a reading project due in those 5 days. So what? It doesn't have anything to do with how many pages will she read altogether. By the way, this is how people write the SAT, the ACT, and most standardized tests. So be on the lookout when you're reading this. Read the question first so you know what you're doing. And notice that if you read the question first, that it actually directs the brain on solving the problem. So you got it. 100 plus 180 is 280. She has to read 280 pages altogether. Let's do some algebra. What? Algebra? Yeah, algebra. The sum of 3 times the number and 7 is 4 times the number decreased by 8. Now you may be saying to yourself, Mr. D, really? Okay, well you're a math guy, so you should be able to do that. And if you're not a math person and you may say, I'd like to become a math person, reading that may be confusing to you. The sum of 3 times the number and 7 is 4 times the number decreased by 8? What in the world is that saying? There's no question. You just said look for the question, but I don't even see a question. All that is a statement. What am I supposed to do with that? The whole idea is to translate it into math so you know what to do with it. Here's the problem with a problem like that. It's how you read this problem. So let's do a little experiment. Here comes the experiment. What I'm going to ask you to do in just a moment is to read what you see on the next screen. Read exactly what is there to yourself. And then what I tell people in seminars and when I'm doing this live in person is raise your hand when you know what it says. So I'm going to pretend that someone in your family raised their hands. Matter of fact, if you're doing this with your young people, have them read what they see, and the first person to raise their hand gets to read it out loud. That's how it works. Are you ready? Now I'm going to tell you a hint. The first word on the next screen is going to be the word Paris, like Paris, France. But be prepared. Moms, if you're doing this with your young people, first person who raises their hand, they get to read it out loud. But you have to do this. Read exactly what you see. Read it to yourself. And then as soon as you know what it says, raise your hand. Are you ready? Here we go. Okay, giving you a second to raise your hand. Mom, somebody's got their hand raised. Great. Call on that person and have them read what it says. Most likely what they said was Paris in the spring, XOXO. And you say, yeah, okay, great. And you might even agree with them and go, yeah, well, that's what I saw too. Somebody else say, no, it said Paris in the spring, hugs and kisses, hugs and kisses. Well, guess what? It didn't say either one of those things. And you might be thinking, what? What do you mean it didn't say either one of those things? Well, remember, the directions were to read what you see on the screen and read exactly what is there to yourself. I'm going to show it to you again, and I'll leave it up a little bit longer. Here it comes. Mom, call on that person as soon as they can see what it says. They're seeing what it says. And now I'm going to have them read it, and this time I'm going to leave it up here. And if you look at it, they're still saying, but it still says Paris in the spring, XOXO. But does it really say that? Well, now you're saying, no, it says Mr. D Math and how to think and talk math. Okay, well, it says that up in the top, but look in the box. What's it say? And you still might be saying, no, it says Paris in the spring, XOXO. So here's what I'm going to ask you to do, because someone asked me to do this one time, because the first time I read this, I said the same thing, just like you might be, Paris in the spring, XOXO. And they told me, they said, listen, why don't you walk up? And I had to do this on a chalkboard. I had to walk up to the front of a room on a chalkboard in a room full of about 200 people. And when I got to there, then what I had to do was I had to go up and literally point to each word because I could not come up with what it actually said. So watch this. Point at each word. Paris in the spring, XOXO. How many of you missed the second the? Literally what I had to do was to go back and read it like a first grader. So let's come to this next phrase. The sum of 3 times the number and 7 is 4 times the number decreased by 8. What we're going to do is we're going to read it like a first grader. What does that mean? Well, we need to know some words. The word sum, if I said to you, okay, I would like you to find the sum, and the next thing I'm going to have to use is the word of. So think about when I see the word sum, it creates a phrase, the sum of something. Well, the sum of what? Well, something and something. So as I'm saying the sum of, I'm something and something, I'm going to go look for the word and, which is right here. That's where my plus sign goes. So I know that I'm adding because that's what the sum tells me to do. But what am I adding? Well, I'm adding 3 times a number. Well, 3 multiplied times a number. I don't know what the number is. I'm going to call it the letter N. And is my plus sign 7. So this is telling me we're going to do 3 times the number and 7. There's my sum. There's my and. So now I'm going to be adding something and something. 3 times the number and 7, which looks like this, 3n plus 7. Now, one of my favorite words in the math language is the word is, and the is I read it like a first grader. If I said to you 5 plus 5 is, you would say 10 because is an equal sign. So now I see I have 3n plus 7 equals what? Well, it equals 4 times the number. That's the next thing I see. 4 times 4 multiplied by the number. Well, that number is still the same n that I didn't know before. It's still n, so I write it as 4n, and then decreased, like a first grader would read it, decreased means to subtract. Subtract by what? Well, we're going to subtract by 8, and you can see now I have this this equation, 3n plus 7 equals 4n minus 8. Now, I know some of you at home right now, as you're watching this, are saying, okay, but what's the answer? Well, that is the answer. Just translate it. But some of you are saying, no, what's n? What's n equal? Well, if you work it out, and you can work this out, and you got this on your own, check it out. You might be wondering, the number was 15. That's the n. The sum of 3 times a number and 7 is 4 times that same number decreased by 8. If I multiply 3 times 15 and add 7, I'll get the same answer if I take 4 times 15 minus 8. That's how that works. Now, if you're wondering how the algebra works, well, check out one of my courses starting at pre-algebra, and we'll go through something exactly like that so you can see how to work it out. All right, now I'm going to let you guys practice one. Here it comes. Are you ready? Get ready, because your turn to practice looks like this. A number increased by 12 is the same as 3 times the number decreased by 4. What I'm going to ask you to do is to pause the video, write it down, come up with your expression, and put the video back on when you've got the answer. Okay, welcome back. Did you get this? N plus 12 equals 3n minus 4. If you did, you translated it exactly right. Now, some of you went ahead and said, yeah, but I'd like to know what n equals. And if you got n equals 8, then you got the answer right as well. If the question was find the number, but there's no question there, or a statement find the number, but there we have it. N plus 12 equals 3n minus 4 is all that's saying. Okay, well, are there rules in your language? Do you have rules in the English language? And you might be saying, well, yeah, of course I've got rules in the English language. Well, guess what? There are rules in our language as well. Our language being the math language. So check this out. You have the rule called I before E except after C when you're doing spelling. Well, we have one a little bit like that in math as well. The rules in math language, here they come. Look at this one, 2 less than 14. Now, if I think about 2 less than 14, I may not know, do I do 2 minus 14 or 14 minus 2? Which one is it? 2 less than 14, well, less than tells me to subtract, but the way this is written is like an I before E except after C, which actually tells me 2 less than 14. What I ask students to do all the time is if you're not sure, make up something you are sure about, like your age. Think of what's 2 less than your age. If you did 2 less than your age, you would say, well, 2 less than, if my age was 14, 2 less than 14 would be 12, which means that I did what? I did 14 minus 2, not 2 minus 14. One would give me a negative answer, but I don't want that. 2 less than my age is actually 12. So it really means 14 minus 2. There's my rule, like an I before E except after C. It does happen when we say 2 less than a number. Okay, well, let's check it out. Are you ready? Read this, translate it, pause the video, come back and see how you did. 3 less than 2 times the number is 5. Pause the video. When you've got your answer, come back and check and see how you did. Okay, did you get what I have? 2n minus 3 equals 5. 3 less than 2 times a number is 5, and there it is. And in case you were wondering, the answer is 4 for the number n, because some of you just have to know what it is, and that's okay. Let's figure that out when needed. Okay, now, there are rules out there in the world of math. There's conventional rules, there's important conventional rules, but did you know there's a super important conventional rule in math? It's called PEMDAS. Some people call it Please Excuse My Dear Aunt Sally. Now, why is this super important? Well, the only reason it's super important is because I made it up and said it's super important. So if something's super important, take it from a math guy like me. If I say it's super important, it's super important. PEMDAS. Check it out. PEMDAS we hear as Please Excuse My Dear Aunt Sally, and it's our order of operations. Well, what does that mean? Well, each of those letters means something. The P, if for please, it means to do everything in parentheses first. The E for excuse is doing the exponents. This is where people get stuck though. My dear, and think about how my dear goes together. It's multiply and divide, multiplication and division at the same time in order from left to right. You go straight across the page from left to right. And then Aunt Sally, same thing, addition and subtraction in order from left to right. Very important. You don't do multiply and then do divide. You do multiplication and division in order from left to right together at the same time, going left to right across the page. All right, let's check out a problem. Grandma's made some cookies. Okay, that's awesome. But look down here. I'm saying how many cookies are there with my question, and I see 3 plus 4 times 5. Now, if you look at what Grandma did when she made cookies, she put 3 cookies in a row, plus she made 4 more rows with 5 cookies in each row. So what does that look like? Well, it looks like 3 cookies in a row plus, well, 3 plus 4 rows with 5 cookies in each row is my 4 times 5. Now, if you think about that, 4 rows with 5 in each row means I'm counting my 4 rows with 5 in each row, like 5, 10, 15, 20, plus the 3 makes 23. Well, wait a minute. Which one is it? Did you do 3 plus 4 and got 7, and 7 times 5 is 35? Or did you do 3 plus 4 times 5 and got 4 times 5 is 20, and 3 plus 20 is 23? Now, if you notice me saying that kind of quickly, you might be going, well, gosh, they both sound right. But which one is it? Well, apply PEMDAS. You do the multiply and divide first in order from left to right, which would do multiplication and division. In this case, just multiply 4 times 5, which is 20. Then go back and do the addition, 3 plus 20, which is 23. I've got a gift for you. You're going to see this that is in the area, and it's linked up, and it says just a gift from me using math common words. Now, what you may not know about me is that I have had an opportunity to travel literally all over the world, and in traveling all over the world, I've had an opportunity to share math concepts with lots of young people, not only here in the United States, but outside of the United States as well. One of the places I got to go and work with young people was in a fabulous state called Hawaii. In Hawaii, I was working with a charter school that they were having trouble with their standardized test scores, and they asked me to come in and help them. So for 3 years, I traveled from my home state of Florida out to Hawaii, and I would spend about a week, and I would work with the students and work with the teachers, work with the staff, and work with the administrators on getting them ready for their standardized test. Here's what happened. They were towards the bottom of standardized test scores for the whole state of Hawaii. After I worked with them for a year, they increased their test scores, not just in math, but in reading as well. They had a 60% increase in math and a 68% increase in reading based on something that I helped them create, which was using common words. And we're going to start with math, and you can do this with other things as well. But if you notice my test-taking skills of starting with the question first, it's one of the first things I worked with them on. Find the question, answer the question, and then we created math common words for the charter school in Hawaii. So what we did from there is this, is they were all in green and pretty and flowery, but yours are going to look kind of more orange like my Mr. D math symbol. But let's check this out. Are you ready? You can print these out, you can put them on the walls, and have your young people look at them from time to time. Every time they see a math word problem, go in and look for keywords, and here they come. Operation. An operation is an action or a procedure that produces something. Think about your operations. Add, subtract, multiply, divide. Now we know those things and we say, oh yeah, those are the operations, but what is an operation? Well, it's just what we just said. It's an action or a procedure that we do that produces something. Watch this. Addition. What's the definition? This is going to sound kind of funny because I'm asking you the definition of addition and you think that you know what it is and you're going to find out that you don't. What do I mean by that? Well, the word addition, you know how to add, but what does it mean to add? What's the definition of addition? Try not to put the word add in your definition. Most people will come up, well, it's the sum of two numbers, or it's putting things together, or combining two or more things. Well, yeah, people do all those things, but that's not what addition is. You know, think about this. If I held up my fingers, and I held up 3 fingers on my right hand and 2 fingers on my left hand, and I said, how many fingers are there? You'd probably say 5. If I asked you why you'd say 5, you say, well, because you got 3 on that side and 2 on the other, and I can see it's 5. The adding part, not really adding. What you're really doing is if I put 3 fingers on my right hand, 2 fingers on my left hand, by the way, try this at home, hold up your 3 fingers, hold up your 2 fingers. Notice you're not putting them together, you're not combining them, you're not doing any of the things that you said was the definition of addition. What you are doing is you're counting them, really. Addition is counting things that are the same. That's it. Now, moms, dads, if you're watching, young people, as you're watching this, check this out. Why can't you add these? 1/2 plus 1/4. Well, you say, well, you can't add 1/4 plus 1/2 because the denominators are not the same. You say, yeah, that's right. You can't add them because they're not the same. So what do you have to do? Well, you have to have common denominators. Oh, you mean like this? Like 1/4 plus 2/4? You say, yeah, you can add those together. Now, you guys, if I said go ahead and add those together, you'd say, oh, yeah, I can do that right now. I'm going to tell you the answer, but then I'm going to tell you a wrong answer. Are you ready for this? Now that I have common denominators and I can see 1/4 plus 2/4 and I add them together, well, 1 plus 2 is 3 and 4 plus 4 is 8. So the answer should be 3/8. You say, Mr. D, that's just wrong. You know it's not 3/8, it's 3/4. And then I think to myself, well, wait a minute. How come you don't add the bottom numbers together? Why did they stay the same? And if your young person ever asks you this, Mom, most moms answers, and most people, when they answer that question, they say, well, that's just because of the way you do it. Well, what if we apply the definition of addition? Here's the definition of addition. Count things that are the same. Well, in 1/4 plus 2/4, what am I counting? You're counting fourths. So what do you got? Well, you got 1/4. You got 2 more fourths. So altogether, what do you have? 3/4. Why do we make common denominators? So we can make them to be the same, so we can count them. What are we counting? We're counting the kinds of fractions that they are, like 1/4 plus 2/4, 3/4. As you can see, pretty easy to do. So let's count things quickly. How about this? How about the commutative property in making tens? Making tens has gotten popular in the last couple years, but making tens has been around way longer than anyone decided to make it popular in the last couple years. And I've been using this for over 20 years, and I know other math people have as well, like me. using the commutative property, making things move around to make tens. Let's say that I went out and I was playing putt-putt golf, and here's my scores. On the first hole I got a 3, and then I got a 4, and a 7, and a 2, and a 5, and a 5, and an 8, and a 6, and a 3 on the first 9 holes, and I want to know what my score is. Well, how would you add this up? Well, most people would say, well, just add it up. 3 plus 4 plus 7 plus 2 plus 5 plus 5 plus 8 plus 6 plus 3. But the commutative property lets me take those numbers, list them, and then move them around to find numbers that work better together. Do you see any 10s up there? Check it out. There's my numbers, but look for 10s. 3, 4, 7, 2, 5, 5, 8, 6, 3. You might say, hey, wait a minute, 5 and 5, that makes a 10. Oh, 6 and 4 makes a 10. Wait, 8 and 2 makes a 10, so does 3 and 7. Oh my goodness. Well, let's just check it all out here and see what we get. So if I did all that, my 3 and 7 makes a 10, 4 and 6 makes a 10, 5 and 5 makes a 10, 2 and 8 makes a 10, and look at that, 10, 20, 30, 40, and 3, just by making 10s. We teach people the commutative property in algebra, but we don't tell them why. Well, here's why. Move things around to make it easier. That's my reason why. How about yours? All right, here's some words that mean add. And again, print this out, put it up on the wall, let your young people add to the list as you see more words that mean add along the way, and feel free to email me those as you see them too. I'll add them to my presentation. Add, plus, more, total, greater, bigger, grow, up, positive, ascend, deposit, increase, and the word sum. The word sum is actually in that little blue bubble because it's the answer to an addition problem. How about subtraction? Most people know the second definition, to take from something that's already there. But they don't think about the first definition that I have, is it's really a way to find out how far it is between things, the distance. What do I mean by that? Well, think about this. So, how far is it from 6 to 14? Now, you might be saying to yourself, well, I know how far it is from 6 to 14. I'll go 6, 7, 8, 9, 10, that's 4. 11, 12, 13, 14, that's another 4, so I went a total of 8. A total, you added 4 and 4 to go from 6 to 14? You did. How far is it? Well, the distance from 6 to 14 is 8. But wait a minute, that's a subtraction problem. 14 minus 6 is 8. How about that? We did it the other way. Going from the bottom, counting up to the top, makes it really easy to do. How about this? How far is it from 23 to 30? You go, well, that's easy. It's 7. Okay, great. How about this? How far from 23 to 40? Watch how easy this is to do. Go from the 23, go up to the next 10, which is 7. Now you're at 30. Go from 30 to 40, which is 10, and you win a total of 17. Hey, wait a minute, that's the subtraction problem. What? How far is it from 23 to 37? How far is it from 30 to 40? 10. How far then is it from 23 to 40? A total of 17, or a distance of 17. How about some words that mean subtract? Subtract, minus, less, negative, descend, take away, down, smaller, withdraw, decrease, and the word difference, which actually is the answer to a subtraction problem. All meaning the idea of finding the distance between things. All right, well, how about this? Multiplication. Let's count things by more than one at a time. 2, 4, 6, 8, 10, 3, 6, 9, 12, 5, 10, 15, 20, and so on and so on. You start counting bigger numbers as well. How about count by 13s? You're like, no, I don't want to count by 13s. All right, well, let's not count by 13s. Let's do some algebra. More algebra? You bet algebra. Let's start introducing it to you now so it makes more sense later on. What do I mean by that? Well, isn't 13 a 10 plus a 3? You say, yes. Well, when I'm going to multiply it by 4, which means I have to multiply both of those by 4 then, because if 13 is 10 plus 3, that would just tell me that I need 4 3s and 4 10s. Well, that seems pretty easy enough. 10 plus 3 times 4 is the same problem, but now we're going to do this. 10 times 4, which is 40, and 3 times 4, which is 12. Well, look at, I've got my total there, 40 plus 12, which is 52. Now, I have a lot more information on this in pre-algebra, algebra courses, and beyond, even up into pre-calculus when you get into there, how you apply all this, but we're going to start taking the numbers out and put even more letters in, and you can see how to work with what we call the distributive property in algebra. You can practice this at home as well. How about some words that mean multiply? Multiply, times, by, and there's my favorite one, of, in that red circle, and the word product. Product is the answer to a multiplication problem. Now, why do I have of circled? Well, think about the word of, like half of 10. And you say, well, I know half of 10 is 5. Exactly. But what you're really doing is 1/2 times 10, which equals 5. Oh, how about that? Most people say, well, yeah, that's because 10 divided by 2 equals 5. But when I say 1/2 of 10, or half of 10, I'm actually doing the multiplication problem, 1/2 times 10. How about division? Separate things into equal groups. And if there's something left over, well, that's if it doesn't fit in the equal group, we call it a remainder. Easy enough. Did you notice that as the operation gets harder, it's easier to define? Go figure. All right, well, here's some words that mean divide. Divide, cut, separate, ratio, per, and the word quotient, the answer to a division problem. Now, why do I have the word per circled in red? Well, think about this word, percent. And you're like, I know that word. That's the one you move the decimal 2 places to the left when you see the percent sign. to change it from being a percent back into a decimal. Really? Well, how did that happen? The whole move the decimal 2 places to the left. Why do you move it to the left? Why don't you move it to the right? All these questions come up. Well, let's look at the word percent and what does it mean? Think about the word per, which means divide. Cent is a prefix for 100, as in century, so percent means divide by 100. By the way, when you divide something by 100, it does make the decimal move 2 places to the left. That's the whole point. So when you've heard the rule, move the decimal 2 places to the left, it's not because it's some rule that some math guy made up, it's because we're dividing by 100. There you go. All right, so what does this mean then? Using common words, what is 35% of 200? Well, the what means I don't know. The is my equal sign. 35% means 35 divided by 100. Of means multiply, and 200, check this out. It looks like this. N equals 35 divided by 100 times 200. And if you actually work that out and you could create fractions and do all kinds of fun stuff with that, you'd get 70. But the idea is, can you translate things into your common words? All right, how about words that mean equal to? Equal, the same as, equivalent, congruent, and the word is that we've talked about before. Is another word that means equal. Well, how does that happen in time? Well, let's look at it. So in time, is happening now. Was is happening before. Will be is happening in the future. So something is now, was before, will be in the future, always another way of an equal sign. But what about when things are not equal? Look at this. We have is less than or equal to, at most is greater than or equal to, and at least. Now I want you to notice here the word is with going with less than is actually very important. If you don't put the is there, it means something totally different. It's an inequality. The equality part means I need the is, the equal sign, but the in part means it's not equal. In this case, we're saying is less than. Or we could say is less than or equal to, where we just go and we just add a little part of an equal sign right underneath it, is less than or equal to, and then at most. Now, this one probably looks weird. At most means is less than or equal to. Let's think about this. Let's say that you are a young person and you would like to go to the movies this weekend. So what do? Well, you've got to do that one very important thing before you go to the movies, and that's visit your local bank. You guys know the bank I'm talking about, right? It's called the Bank of Mom. Anybody ever been to that bank before? And you say to your mom, you go, Mom, I'm going to the movies this weekend, and before I go to the movies, I need at least $20. And Mom says, really? Well, at most you're going to get is $20. Anybody ever been in a conversation like that before after visiting the Bank of Mom? It's kind of how the Bank of Mom works. The Bank of Dad works that way too. So young person will say, I need at least $20, because what are they asking for? Well, they want $20 or more is greater than or equal to. When Mom says at the most you're going to get is $20 means $20 or less, because you can have up to $20, but not more than $20, which means is less than or equal to. All right, well, here we go. You have found the math common words from Mr. D Math, and you've had an opportunity to spend some time with me in my world of how we take math and create it as a language. I hope you found this presentation useful and enjoyable. The notes are in this section as well. If you can see, you can click on those and download that, as well as the math common words. So enjoy. If you've got questions along the way, don't hesitate. Send me an email. I'd love to hear from you. I'm Mr. D from Mr. D Math. Thanks for listening and watching.